All right, we are back for example 2. A production manager at a wall clock company wants to test their new wall clocks. The designer claims to have a mean life of 16 years with a variance of 16. So let's go ahead and write that out. We got a mean life of 16 years and a variance of 16. So variance is sigma squared. Before we read the rest of the problem, our equation calls for standard deviation. So that's what we're going to find. And to get standard deviation from variance, we basically just take the square root. So once we square root, we get sigma, standard deviation, is equal to 4. And this is what we are going to use, not the variance. Okay, continue reading. If the claim is true, in a sample of 48 wall clocks, so we got a sample of 48 clocks. So I'm going to go ahead and write n is equal to 48. What is the probability that the mean clock life would be greater than 15.3 years? So what is the probability that the mean clock life, so it's the mean of this sample of 48 clocks, is greater than 15.3? All right, just like the last problem, we got to standardize. We got to figure out the z. Z is greater than what? What's that z? So let's transform. Z is equal to x bar minus mu divided by sigma over the square root of n. Okay. So our x bar in this case is 15.3. That's coming from the probability statement. And then the rest of the numbers come from what we found in the problem. So 15.3 minus 16 all over 4 divided by square root of 48. So pop that into a calculator or use that online calculator. You will get 0.52. Just one quick note, if you're choosing to kind of just work this out by hand, like find the top, find the bottom, and then divide those two numbers, that's totally fine. Just be very careful. And when you do this bottom number, I would do it to like maybe 5 or more decimal places. If you don't include enough decimal places, there's going to be some rounding error because you'll eventually have to round this bottom number. And then you're going to do some division. And if you round a little too early, essentially, your actual answer might be off. So if that's what you're doing, just make sure you write this bottom number out to many decimal places, and then you can do the division. Otherwise, just use that Desmos calculator because it kind of just does all that for you. It's fantastic that way. Okay, so we figured out z is 0.52. All right, so I'm going to draw a quick picture, see what we're working with. Curve, okay. So 0.52, that's right about here. Okay, so I'm going to cut the curve up at that point, and we're trying to find the probability that z is greater than that. Greater than means we shade to the right. So we're trying to find area to the right, which, remember from the chapter 8 videos, the z tables don't give us area to the right, they give us area to the left. So to figure out area to the right, we do 1 minus the area to the left of that same value. So we're going to look at 1 minus the probability that z is less than 0.52. Okay, z table it up. 0.52. Oh, I already have it highlighted. Why, you ask? Because this is the second time I'm making this video, because that happens. Anyway, 0.52, look for it, and we end up at 0.6985. So 0.6985 do that subtraction, and you end up with 0.3015. So that's our answer. And what that means, again, is, if we randomly choose one of those samples of 48 clocks, what's the probability that the mean of that specific sample is going to be greater than 15.3 years? And it's kind of a smallish probability, 0.3015. Okay, I'm going to go ahead and do the next example in another video. I will see you then.